Gravity is the compass and the undertaker of the stars. It gathers clumps of gas and dust from the interstellar clouds, compresses them, and if they are sufficient massive, ignites thermonuclear reactions in their cores. Then, from millions or billions of years, they produce energy, heat, and pressure which can balance the inward pull of gravity. The star is stable, like the sun. When the star's energy sources are finally exhausted, however, gravity shrinks the star unhindered. Stars like the sun contract to become white dwarfs, a million times denser than water and supported by quantum forces between electrons. If the mass of the collapsing star is more than 1.44 solar masses, gravity overwhelms the quantum forces, and the star collapses further to become a neutron star, millions of times denser than a white dwarf, and supported by quantum forces between neutrons. The energy released in this collapse blows away the outer layers of the stars, producing a supernova. If the mass of the collapsing star is more than 3 solar masses, however, no force can prevent it from collapsing completely to become a black hole. A black hole is a region of space in which the pull of gravity is so strong that nothing can escape. It is a hole in the sense that things can fall into it, but not get out. This is black in the sense that not even light can escape. Another way to say it is that a black hole is an object for which the escape velocity, the velocity that's required to break free from an object, is the escape velocity that is greater than the speed of light, the ultimate speed limit in our known universe. Black hole comes in different varieties and can be modeled with different levels of complexity, like whether or not they spin or have an electrical charge. So, if we jumped into one, our exact fate might depend on which sort of black holes we choose. There, let's take 3 examples. If the black hole is larger enough, you may cross the event horizon and notice nothing for a long time. In another choice, if the black hole is spinning extremely fast enough, its angular momentum wraps space-time itself. This causes you or me to spin around the black hole as you get near to it. And another point can be like, as you approach the event horizon, less of the universe's light can reach you before being sucked into the black hole. At the simplest level, there are 3 kinds of black holes: stellar mass black holes, supermassive black holes, and intermediate mass black holes. Stellar mass black holes form when very large stars finish burning their fuel and collapse into themselves. Supermassive black holes live in the center of the most galaxies and likely grow to their extreme sizes up to tens of billions of times more massive than our home star Sun. By consuming stars and merging with other black holes, intermediate black holes are still existing. Intermediate mass black holes are still mysterious and only a few suspected examples have been discovered. But astronomers think they may form through a similar process of accretion just on a small scale. coming back, a black hole is a very simple object. It has only three properties: mass, spin, and electrical charge. Because of the way in which black holes form, their electrical charge is probably zero, which makes them simpler yet. The form of the matter in a black hole is not known, partly because it is hidden from the outer universe, and partly because of the matter would, in theory, continue to collapse until it had a radius of zero, a point mathematicians call a singularity of infinite density, something with which we can have no experience here on the earth. Wrapping up everything with enough rocket fuel, our spaceship can do few miracles. Escape is always possible as long as you can still see some light and have therefore not crossed the event horizon. However, if we escape getting sucked into the black hole, we will likely never see our neighborhood, our families, our friends, or our planet Earth, since thousands of years have probably passed on your home planet during the minutes you spent near the event horizon. Making it in simple terms, wrapping up the complete subject, if we fall into a black hole, as you approach the black hole, you gradually start experiencing its strong gravitational pull. As you move closer to the black hole, you will be accelerated to high speeds compared to the speed of light. However, for people watching you from outside, you would appear to fall into the black hole in slow motion. This is called due to the time dilation. This will continue until you reach the event horizon. Here, time stops relatively and reality splits into two. As time stops, people on the outside would see you freezing at the event horizon. In fact, due to strong gravitation, light emitted by you will be redshifted by the time it reaches their eyes, and they would never actually know what happened to you. But for you, time will run normally inside the black hole. You will see the entire future of the universe unfold in front of you in a matter of moments. This will continue until you finally reach the black hole's singularity, where you are either crushed by the infinite gravity at that point or teleported to another universe.